All right, let's jump right into a topic that is absolutely crucial for the CPMAI exam, the task of labeling data. If you can nail this concept, you are seriously on your way to passing. So let's get you there. Here's our game plan for today. We're going to start with the basics, the why behind it all. Then we'll get into the official PMI framework you have to know. We'll talk about how you prove your data is good enough. We'll look at the common traps PMI sets on the exam, run through some quick scenarios, and then wrap up with the stuff you absolutely have to burn into your memory.
Okay, let's start at the beginning. To really get what data labeling is all about, I want you to forget the technical stuff for just a minute. Let's use a really simple metaphor.
I want you to think of yourself as a flashcard creator. And your student? Well, it's an AI model that knows absolutely nothing about the world. That's your AI at the very beginning. It's just a blank slate. It has this incredible, almost limitless capacity to learn, but it starts out completely empty. It's just sitting there, waiting for you, the teacher, to give it a lesson. And this is data labeling in a nutshell. Every single time you tag a photo as cat, you're making a flashcard. You're creating a perfect little piece of knowledge that teaches the model this is what a cat looks like. This is how the AI builds its entire understanding of the world. Okay, so let's snap back to the official CPMAI world. Where does this fit in? Data labeling lives right in the middle of Phase 3, data preparation. This happens after you've figured out the business problem in Phase 1 and you've explored your data in Phase 2. Phase 3 is where you roll up your sleeves and get that data ready to actually build a model.
So you might be wondering, why is this one single task so important? Why does it show up so much on the exam?
And here's the bottom line, the thing you have to remember. The quality of your flashcards directly dictates how smart your toddler becomes. If you have sloppy, incorrect labels, you're going to get a confused and useless model. But if you have pristine, high-quality labels, what the exam calls the ground truth, that's how you build a powerful, reliable AI.
All right, let's break this down into the specific framework that PMI expects you to know cold. These are the building blocks you'll need to correctly answer those tricky exam questions.
First up, the term ground truth. Now, this isn't just a pile of labeled data. It's the data set that you trust 100%. You verified it, it's accurate. Think of it as the official answer key for a test. You use it to teach the model, and you also use it to grade the model's performance later on.
Next up, labeling guidelines. Honestly, this might be the single most important document you create in this whole phase. This is the rule book for your labelers. It spells out exactly how to label everything, especially the tricky edge cases. Without this, you get chaos, inconsistency, and that poisons your ground truth.
So the whole process is actually pretty straightforward when you lay it out. You start with your input, just raw, unlabeled data. Then you apply the process. You tag that data following the strict rules in your labeling guidelines. What comes out the other end is your output, the labeled dataset. And if you did it right, that becomes your ground truth. The key deliverable that proves you had a quality process? That labeling guidelines document itself.
Now, as the project manager, you're not the one doing all the clicking and tagging. Your job is to make the big decisions. You have to define what quality even means for this project. You have to decide who's going to do the work. You have to set up the quality control process. And most importantly, you have to make that final go, no-go call on whether the data is good enough to move on to Phase 4.
So that's the big question, right? How do you actually know when your ground truth is trustworthy? When can you confidently say, yep, this is good enough, let's go build a model?
I love this quote from the source material. You should really let it sink in. It gets to the heart of the matter. If your labels are a mess, any problem you see later with your model, well, it's not really a model problem at all. The real issue is that your ruler, your way of measuring reality, the ground truth, is broken from the start.
And this is absolutely crucial for the exam. Achieving quality isn't a one-time event. It's a loop. You start small, you label a sample batch, you check it for consistency, you find all the confusing gray areas, and then, this is the key, you go back and you refine your guidelines to make them crystal clear. Only then do you scale up and label the rest. So, what's your proof that this task is done and done right? Well, you have two main artifacts. First, the final approved labeled dataset. And second, that signed-off labeling guidelines document. And always remember the connection to the future. Way down the line in Phase 6, when a model is live and suddenly starts failing, the investigation is very likely to lead right back here, to a blind spot in your original ground truth.
Okay, let's talk about the exam itself. PMI is smart. They set traps to see if you're really thinking like a project manager. So let's look at some common wrong instincts and contrast them with the correct PMI-aligned move. The first trap is the pressure to just get started. Your gut might say, let's just throw the data at our experts. They're smart. They'll figure it out. That is the wrong move. The correct PMI way is always process first. You have to create, debate, and get formal sign-off on those labeling guidelines before anyone labels a single piece of data at scale.
Trap number 2 is underestimating inconsistency. It's so easy to think, some labelers see it one way, some see it another. It'll all just average out in the big data. Wrong. For the exam, low agreement between labelers is a code red emergency. It is a quality failure. The only correct action is to stop the line, fix the root cause in the guidelines, and retrain your team.
And the last big trap is thinking of this as a straight line. The wrong instinct is to see labeling as a task you just do once and check off the list. The correct PMI mindset, as we've been saying, is that it's iterative. It's a loop. A good project plan has to account for these quality checks and even the possibility of relabeling right from the very beginning. All right, enough theory. Let's put this into practice. We're going to run through a few quick scenarios that are designed to feel just like the questions you'll face on the CPMAI exam. Okay, scenario 1. Imagine you're a PM and you're putting together a guide with pictures that clearly shows the difference between a hairline crack and a scratch on a phone. What phase are you in? The answer is phase 3, data preparation. And the dead giveaway here is the artifact being created. The PM is making the labeling guidelines. That specific document, that rulebook, is a core activity of phase 3. It's what you do before the real labeling work begins.
Scenario 2. You've got a big problem. You run a check and discover your labelers only agree about 60% of the time on what makes a customer ticket urgent. As the PM, what is your very next move? Your next move is to halt labeling and refine the guidelines. Remember that exam trap we talked about? Low agreement is a critical quality failure. You don't just keep going. You don't average the results. You stop the production of bad data immediately, and you go fix the process at its source, which is the ambiguous guidelines.
Okay, last one. Your AI model is live, it's out in the wild in phase 6, but it's suddenly failing to catch a brand new type of fraud. When you investigate, you realize this fraud category never existed in your original training data. What must be in your plan for the next project iteration? The answer is you have to plan a return trip to phase 3. This is a perfect example of the cyclical nature of AI projects. The problem isn't the model's brain, it's what the model was taught. It's a data gap. The only way to fix it is to go all the way back to data preparation, collect examples of this new fraud, and label them to update your ground truth.
All right, we have covered so much ground. Let's boil it all down now into the most important high-yield facts. This is the part you want to screenshot or jot down for your final exam cram session.
Let's start with some if-then rules. Think of these as mental shortcuts for the exam. If you see words like tagging or annotating, your brain should immediately go to phase 3. If the question mentions low labeler agreement, your first action is always to refine the guidelines. If the guidelines are vague, you know it's impossible to create true ground truth. And if a live model starts failing on new things, you should always suspect a data gap from phase 3.
Now, if you're making flashcards, these are the 5 key items to put on them. 1. Phase 3, data preparation. 2. The term ground truth. 3. The artifact labeling guidelines. 4. The process, the iterative quality loop. And 5. The critical rule, low agreement equals a quality failure.
And if you forget everything else from today, please just burn these 3 takeaways into your brain. Number 1, data labeling happens in phase 3 and its whole purpose is to create the ground truth. Number 2, quality is all about having clear labeling guidelines and stopping everything to fix low agreement. And number 3, the process is a loop. It's iterative, not a one-and-done task.
And that is our deep dive on data labeling. As you study, don't just memorize these terms. Really think about the logic behind them. And I'll leave you with a final question to chew on for your own work. On your next AI project, what specific actions will you take to guarantee that your ground truth is solid enough to build a business on? Thanks for joining me, and good luck with your studies.